Hello, my name is Tony Botting and I'm a simulation specialist at GoEngineer. Today we'll talk about developing an animation of a time-dependent heat transfer plot in flow simulation. This is a unit section of a steel panel with channels for cooling fluid. The steel section starts out hot and a cool fluid is introduced into the channel. The customer is interested in the time it takes to cool down. This is a transient conjugate heat transfer analysis, and we'd like to visualize the temperature in both the fluid and the solid as a function of time with an animation of a cut plot. This animation shows what we'll be doing. You can see the fluid temperature change and the solid temperature change as a function of time. Okay, the first thing you'll want to do here prior to running the analysis is go into Calculation Control Options. Here you can see we've got it set up for 1800 seconds, and we're going to do periodic savings. The units are going to be physical time. We'll start at 0 and save every 60 seconds. You can also do tabular savings and tell it to save at units other than the 60-second interval. Now we'll go ahead and run the analysis. What we're doing is monitoring the average temperature of the solid and the outlet temperature of the fluid. So you can see the graphed lines there below, and the red line is the solid temperature coming down, and the green line is the fluid temperature at the exit. Initially it heats up and then they both start to cool down together. So this is what we're going to generate our animation on. Okay, so what you want to do here is go ahead and load up a results file. You can load up any of the results sets that were saved. And we've generated a cut plot, so we'll show that. That's the temperature in the solid and the fluid. So go ahead and right click on the cut plot and choose Animation. And that'll open a panel below, and we want to click on the More button. And that'll show the results timelines for cut plots 1 and 2. And what we want to do is use the wizard. And we'll click on the wizard button, and we'll do an animation time of 10 seconds. And we're going to delete all the existing tracks. Make sure to do that. Click Next, and we do not want to rotate the model. But instead of doing loaded results, we're going to do this thing called Scenario. And Scenario will take all of the results and load them for you. We'll do uniform time distribution using physical time instead of iteration, and we'll start from 0 and end at 1800. And there you can see the olive colored triangles on the results row representing the results files that have actually been set up for load. What you need to do now is right click on the cut plot row and choose Insert a Control Point. And this will gather all that data for that cut plot and stretch it out to the end of the animation there at 10 seconds. So now we'll go ahead and click the play button, and you can see it loading each set of results represented by the olive diamond there, coloring it appropriately. In this video we've showed how to set up an animation for a time-dependent heat transfer plot in flow simulation.